question 10, so we're doing question 11, 12. Yeah, I don't know where we're going to end. So the first question is limit as x is approaching 0 from the right side of the modulus x divided by x, and also we need to find limit as x approaches 0 from the left side. So allow me first to teach you this. I'm going to teach this question in such a way that in a case where you have been given find the limit as x is approaching just 0 of the modulus of x divided by x. So the way I'm going to be solving this question, I'm going to be solving in two ways. Okay? So I'll be solving the limit as x is approaching 0 from the right side and from the left side. But I've just changed this question to say in a case where, because I know sometimes they can give you this question. Okay? So when you've been given such kind of question, the first thing which you have to do is when limit is approaching 0, you have to test both sides. Limit as x is approaching this 0 from the left side and from the right side. If the limit is going to be...
I can't see the screen. I don't know if I'm going... Okay, you can also...
So if the limit as x is approaching 0 from the left side, if the limit as x is approaching 0 from the left side of this f of x is equal to limit as x is approaching 0 from the right side of f of x, then the limit exists. If we are going to find different answers, then the limit doesn't exist. So they are going to ask you to say, find the limit as x is approaching 0, just like that. But to solve this question, we have first to solve this and that, then we compare. That's why I'm telling you to say, I've changed this question to this one. But, mind you, we're going to be solving this and that. But as we are doing that, we are also solving this question which I've given you. Does that make sense? It's making sense, right? Is it making sense? Okay, so we are going to start with limit as x is approaching 0 from the left side. So we are solving this.
I don't know if
Yes, it's your
I
network.
can't see the screen.
Yes, it's only you.
Lord. Okay.
Yes. So try to leave the meeting and then join again.
Okay, let me get in.
Sure. Okay. So I'm going to start with limit as x is approaching 0 from the left side. That would mean to say I'm solving this. Next, I'm going to solve that. Then I compare. If this is going to be equal to that, then the limit exists. The limit of x as a limit as x approaches 0. Because I saw last time they brought this question. Okay? So I'll start with limit as x is approaching 0 from the left side of x modulus divided by x. One thing about the modulus, one thing we need to know, guys, is this. Here, when we're talking about if this is my graph, I have got 0 here. This is 0. So as x is approaching 0 from the left side, we are coming from the left side here, approaching 0. Okay? So what I'm going to do, the easiest way to find this is to do this. The easiest way to find this is I'm going to have my coordinate here. So I'll have x, y. So I'm going to be putting numbers. Those numbers I'm going to be getting from the negative side because x is approaching from the left side. So from this point, approaching 0. So those numbers, they're supposed to be closer to 0. When we say x is approaching 0, we don't necessarily mean x is equal to 0. But as x is getting closer to 0, what would be the value of y? You understand? Okay. So I'm going to be getting, I'm going just to choose 3 numbers. Okay, those numbers, they're supposed to be closer to zero. So I'm going to start with negative 0.1, then I'll go with negative 0.01. These numbers are closer to 0. 0, 0, 0, or I'll just put two zeros there, like that. Even if you get two coordinates, fine. Then if I put negative 0. I clearly know, guys, to say this modulus here, if I'm going to do the first one, the modulus of that divided by negative 0.1, what would be the answer? Guys, you can do this. What would be the answer here? What would be the answer, guys? We are just dividing here. Okay, the answer will be negative 1. So this is going to give me positive, but this is negative, so it's going to be positive 0.1 divided by negative 0.1, so it will be negative 1. Even when I plug in this guy, I'm going still to get negative 1, so you end up having negative 1, negative 1, negative 1. Have you seen what's happening? So in this case, we can clearly say that limit as x is approaching 0 from the left side of this guy is equal to negative 1. That's the answer. Then I can also do for positive part. It will be the same thing. Don't you think it's going to be the opposite? Limit as x approaches 0 from the right side of this. I'm going to be plugging in positive values now here, because the numbers now are coming from the positive side, from this point going closer to 0. So I'll end up having if I plug in here, I should get a positive. So all the answers here are going to be positive. So it's going to be 1, 1, 1. So the answer here is positive 1. What will be your conclusion here? The question I gave you, to find the limit as x approaches 0 of the modulus of this divided by x. Are you going to say the limit exists? It does not exist. So the limit does not exist because from the left side and from the right side, they are different. Does that make sense? Then you need also to know the question which I sent. There's a link I sent in the group. I sent this night. You need to know that one as well. It's very important. I saw it in 2022. It came. Okay, so know that one. So then let me go to question 12. Determine the points of discontinuity, if any, of the function such that f of x is equal to that if x is not equal to negative 2, and f of x is equal to 0 if x is equal to 2. Do you understand this question? Do you understand this question? So what is happening here? We know that if you plug in negative 2 here, the answer is going to be 0 over 0, which is undefined. We don't want this function to be defined. We want to identify, okay? We want to identify the point of discontinuity. So now, they're saying determine the points of discontinuity, if any, of the function such that. So now, what is happening here is this. For this function to be defined, the first discontinuity is going to be at x is equal to -2. At that point, it has to jump because that is my vertical asymptote. But what of another one? They are saying that if x is equal to 2, if f of x is equal to 0, and f of x is equal to 0 if x is equal to 2. So we have been given one hint, but we need another one. So what we do, such kind of question is this, guys. I need to simplify this such that when I plug in 2, the function has to be defined. Then at that point, it's not going to have discontinuity. Is it making sense?
Yes.
I need to make this function, when I plug in 2, it has to be defined. Okay? Because right now, if I put 2 where there's x, it's going to be undefined. So how do we do that? Okay, so what I'm going to do here is x squared minus 4 divided by this. I know that on top there, on top there, I'm going to have what? It's a difference of 2 squares, so it's the same as x minus 2, x plus 2. So I'm going to rewrite it here. I divide this by x plus 2. So these, they can cancel. Then I'm going to have x minus 2. This is what I've found. And we've been told that if you plug in 2, the question is, and f of x is equal to 0. When you plug in where there is x in this function, now we have got this function. So this is the function we have found now. F of x is equal to x minus 2. So we have been told that if x is equal to 2, y has to be 0. X is equal to 2, y has to be 0. So if I plug in 2, indeed here I'm going to get 0, which is true, right? How do you present your answer after doing this? This is what you are going to do. You are going to present your answer in piecewise function. That would be the best way. You present your answer in piecewise function. So you say, the first one you have been given already, there is nothing like to think there. The first one you have been already told that this function, for it to be defined, x has to be not equal to -2. So I'll just copy the way it is. I'll copy x squared minus 4 divided by x plus 2, comma, x. So I'll say if, for this function to be defined, then if you want, you can just put comma, or if x is not equal to -2. Another one is the one we were driving now, which is this. We have, after cancelling these, we have found that x minus 2. I'll put here x minus 2. For this function to be defined, x has to be equal to what? X has to be equal to 2. Confused?
So that's how you answer that question.
Yes, so here we are trying to identify if we have got the point of discontinuity. So now, the way I've put my answer here, I can clearly see that the point of discontinuity is going to be at x is equal to -2. Okay? Another way on how they are going to ask you this question is, they are going to say, how do they ask? They are going to say, I don't know if I can say solve this function so that it should be continuous. That would be another question which they are going to ask you. Okay? So here, determine the points of discontinuity. If you want, you can sketch it. Okay? If you want, you can sketch it. But again, what I've done here, I've realized to say, if I plug in 2 direct, I'm going to get 0. So what should I do? I should make this function to be defined. Okay? So it can only be defined at when x is not equal to negative 2, meaning my discontinuity is that x is equal to negative 2. Okay, but again, to make it defined, that's why I've put it x minus 2, x has to be equal to 2, because I've solved here, and for use here we have been told that if f of x is equal to 0, x has to be 2. And from what we have found here, if I plug in x, if I put 2 there, I'm going to get 0, which is correct. Do you still have questions? I think you are going to understand. Let me just go to the next question. You'll be able to understand more. You'll be able to understand more, especially on this part. The next question. Okay, any question first before we move? So initially, here I think I've solved 2 questions already. If they ask you a question to say, you need to make this function such that it should be good, discontinuous, or it should be continuous. What I've done here exactly, then I need just to put it like the way I've done it here. But if you can clearly see here, guys, if I want to see the point where I'm going to have discontinuous, it is only at x, because here we are saying that x is equal to 2, meaning at that point I'm not going to have discontinuous. It's going to be continuous because x is equal to 2. But the only point where it's going to be discontinuous is that x is not equal to 2. So, how do we write the answer? If I may ask you. Okay. So it's the same thing. So the discontinuous is going to be just at x is not equal to 2. Here you are just telling them that at x is equal to 2 is going to be defined. So I've taught you two questions here. If they ask you to say make this function to be defined, you also put it like this way. Then if they ask you the way this question is, determine the points, you can put it in this way if you want, or you can just say the only point where it's going to be discontinuous is at x is equal to negative 2. Does that make sense? Does that make sense? I wanted to show you this one. Have you seen this question the way it is? Find the point of discontinuity, if any, of the function such that f of x. So for any piecewise function, you need first to sketch. Once you sketch, where you are going to have an open circle, meaning it is discontinuous. You remember what we used to do, right? So here I'm going first to write the Tuma coordinate. I'll start with x is greater than or equal to 2, starting from 2, 3, 4. Should I put all the way to 4? Okay. So if I put here, if I put 2, it's going to be 2 plus 1, which is 3. If I put 3, it's going to be 4. If I put 4, it's going to be 5. I'll go to the next one. The next one we've been told that from 1 to 2. So I'll write here 1, 2. That's all. If I put 1, 1 times 2 is 2. 2 minus 1 is 1, right? 2, 4, 3, right? I don't know who is confused already. You can just ask. I'll be able to explain. We are good to go. Okay. Then the next one is this one. It's saying that x is less than or equal to negative 1. Oh, 1. So meaning that from, I'm going just to start from where? We can start from negative 1, 0, 1. It's fine. Only 3. They are enough. If I put negative 1 there, I'll get negative 2. I'm plugging in the values there. If I put 0, I'll get neg 1. If I put 1, 0. So let's have our graph. Chengo, are you still here?
Yes, I'm back.
Okay. So what is happening now is this is x, this is y. I'll start with the first one. It's okay. So in x, I can clearly see that I've got 1, 2, 3, all the way to 4. So I'll say 1, 2, 3, 4. If you want, you can put the 2 numbers. Don't worry. Then here, negative side, we were going all the way up to 2, but I am going to extend to 3. So neg 1, neg 2, neg 3. Then in y, we have 1, 2, I'll extend to 3. It's fine. So I'll put neg 1, neg 2, neg 3. Here, all the way to, we have got 3, 4, 5. 1, 2, we don't have 2. Okay. I'll just say, I'll just put the numbers which are there. I'll put 1 here. No one is going to penalize me. I can jump and go to the next number, 3, because I don't have 2. But if you want, you can put 2 here. It's fine. Then 3, 4, 5. It's just sketching. So I'll start with the first one. The first point, get me right here, guys. X is greater than or equal to 0. Oh, sorry, 2. The first one, which is this point here. If we are talking about greater than or equal to, at that point is going to be crossed because 2 is included. So the first point, 2, 3, 2 is here, 3 here. This point is going to be included. Let me put it straight here. This point here, it has to be included. I'm going to put an open, a closed circle because it is included. Then we go to the next one, which is 3, 4. 3, 4, it can be here. Then 5, 4, so it's going there. We don't know where it is ending. I will just start a line there, going this side. Then I need to put an arrow because I don't know where the graph is ending. So this graph which I've just sketched here is the graph of y is equal to x plus 1. This one. For the condition is that x is greater than or equal to 2. I go to the next one. The next one is telling me that 1, 1. But at 1, 1 here, this is just an open. Even if you don't know what is the meaning, if I say this, it's the same as x is greater than 1. But even if you don't know the meaning of that, just know that since it's just less than, there is no equal to, then it is open at that point. You get my point, right? It is open at that point. So I'll go here and say 1, 1 is open. Where is 1, 1? 1, 1 is here. Okay, so I'll put an open. It is open at that point. Next, 2, 3. So 2, 3. Again, it is also open. You can clearly see that it's just less than. So even 2, 3, which is this point here, it is also open. So I'll just join a line there. It ends there. That come up, this line I've drawn here is a graph of y is equal to 2x plus 1, for which 1 is less than x, x is less than 2. Perfect. Next, I'm going to go to the next one, which is negative 1, 2. So we are saying that okay, this one we are only interested in 1. So I'm going to start from 1, 0. 1 is here, 0. So it is at this point. Let me use red now. At that point, it is included. Okay. Then 0, negative 1 is here. It's just a point. Then negative 1, negative 2 is here. It's just a point as well. Just there. So this one starts from there, going this side. but we don't know where it is ending, just put an arrow. The question is, find the points of discontinuity, if any, of the function f of x such that we have been given here. The point where it's going to be discontinuous, it is the point where you are going to have an open. Does that make sense? The point where you're going to have an open circle, at that point it is discontinuous. What point is that? So the point you are looking at x, which value of x do we have an open circle? Hello? Which value of x do we have an open? 1. So you say the only discontinuity which we are going to have here is that x is equal to 1. So at x is equal to 1, that's where we're going to have discontinuity. Now, the question comes here. Why are we saying 1, but the other function we are including 1 here? So yes, quite okay, we are including 1, but it is jumping from here, unless if this line here, if this guy was coming here all the way to this point, then it was an open that point. Yes, we can say it is continuous. But because at this point it's just open, then there is a gap in between. So this is what we call jump discontinuity. Does that make sense? So in a case where you have got something like this, let's say this is continuous, it's going there. Another one is also continuous, same point. This is, let's say it's -2, same point. It is also here, it's going there. Then in between we have got a point, just a point, also like that. Or I can even show it like this. This one has to be open, open. It's open, this is also open at 2. But again, I've got a point. Do you know that if I've got x, I've got any function, then x is equal to -2, it's going just to be a point like this. That's a point. Still, it is going to be at x is equal to -2 because I've got gaps in between here. So it is still discontinuous at x is equal to -2 in that case. But in this case, it is discontinuous at x is equal to 1. Do you know how to, if they ask you to say, how to know, for example, let's say, show that the function is continuous at x is equal to 2, or let's say show that the function is not continuous at x is equal to 1. Like in this case, I think you have learned those 3 principles, right? Hey, like guys, oh my god. Now, let's say they ask you a question to say, I'm going to use this. So now I want us to prove that indeed at x is equal to 1, it is discontinuous. For you to prove that the function is continuous, you need to know that f of 1 has to be defined. That's the first thing. You know what it means when you say it has to be defined? Should not be equal to 0 over 0, or a number over 0. Then another one, limit as x is approaching that number. Let me use this first. I need to explain more here. Sometimes they're going to say, show that the function is continuous at, they're going to give you the value at x is equal to maybe 2. So in this case, I'm going to show that is it continuous at x is equal to 1 or not. In this case, we have said it's not continuous, but let's see if it is continuous or not. So the first point for you to know that the function is continuous at that point, f of a, I'm just using a can be anything, it can be x, has to be defined. You can write this, has to be defined. What I mean is it should not be 0 over 0 or a number over 0. Then 3 or 2, another point is should be limit as x is approaching a of f of x has to exist. Has to exist. What do we mean when we say exist? So here I'm going to have just a baby a limit, or I can just put here, just down here. So for 2, it has got this principle, the one I was teaching you about, the one I was telling you about at the first. Limit as x approaches f from the left side of f of x should be equal to limit as x is approaching that number from the right side. If these two guys are okay, this guy and this guy, but in most cases it's just this one. So if this and that, they are cool, okay, then also I'm going to conclude that limit I'm going to conclude that limit as x is approaching, okay, limit as x is approaching a of f of x, I'll do this. Limit as x is approaching a of f of x is equal to f of a. Then the function is continuous at that point. Should we go ahead now? Everyone is quiet.
Yes, we can go.
So let me start with this. Let me pick a number. Should I pick at 2 is continuous? Let's start with 2. We see. When I say f of 2, I want you to understand this. So I'm going to say, is the function continuous at x is equal to 2? Is the function continuous at x is equal to 2? So the first thing is f of 2. F of 2, which function do you think includes 2? We have got 3 functions. This one, that one, that one. Which one does it include 2 among those ones? The first one. So I'm going to get x plus 1. Then let's plug in 2. 2 plus 1. We're going to get what? 3. Leave it there. So I've gotten the first one because the first condition is that f of 2. So which function include 2? So you go to the one which is saying 2, but it is including, so it's greater than or equal to 2. We're starting from 2. Next, limit as x is approaching the same number, which is 2, which have been given, but from the left side. Which one is telling us that it can be x as x is approaching this number from the left side? Do you know what it means when I say it from the left side? From the left side, I'm going to get a function which is telling me that x should be less than 2. It can be less than or equal to, but it should be less than the second one. So if I get the second one is 2x minus 1. So where there is x, let's put 2. So I'll have this. So I'm going to 4 minus that one, I'll end up having this. Again, I need to get from the right side. Get me right there, guys. I need again to get limit as x is approaching 2 from the right side. Which function is telling me that x should be greater than, it can be greater than or just greater than equal to 2? Which one? The first one. So the first one is x plus 1. I'm going to plug in 2 where there is x. From the graph here, we have said that at that point it is continuous because there is a crossed one inside there. And for sure here we can see that limit as x is approaching 2 from the left side and from the right side we are still getting 3. At the same time, even f of 2 is 3. So therefore, the function is continuous at x is equal to 2. I can pick any number from this point here. Let me tell you, from 2 going this side I can get 3, 4, 5. It's going to be continuous at that point. You can even try at your own time. Now let's try 1. We're saying that when x is equal to 1 it's not continuous. Is it true? But here this question was just trying to tell us determine whether it is continuous. You can't use this method I'm telling you here. You only use the table, sorry, the graph. This one I'm showing you here is when they ask you to say, is the function continuous at a certain point? They're going to give you that point. So it's the one we're going to be following. Let's try 1. f of 1 is equal to, which function includes 1? Come on guys. Which function include 1? The third one, which is x minus 1. So let's plug in 1. 1 minus this, I'll end up getting 0. Let's see. So the remaining 2 I'm supposed to get 0 as well for me to conclude that it is continuous. The moment I'm going to find just 1 which is different from the first one, then it's not continuous at that point. So let's go to the next one. So I'll say limit as x is approaching 1 from the left side. Which function am I going to get? The one which is telling me that x is less than 1.
The second one.
The second one is telling me that x is less than 1 is less than x, which is the same as x is greater than 1. The one which is telling me it can either be less than or equal to, but it has to be that number. X approaching 1 from the left side. Which one are we going to get? The third one. The third one is x minus 1. Let's plug in 1. 1 minus 1 is 0. Let's see the third one. So if the third one now we are going to get also 0, which is from the right side, then definitely we are going to conclude to say what we have solved here to say at x is equal to 1 it is discontinuous, it is wrong. So we are remaining with 1. Let's see if we're going to get 0. So 1 from the right side, which one are we going to get? The one which is telling me either x is greater than 1, it can even be greater than or equal to or just greater than 1. Which function?
The second one.
The second one. The second one is saying 1 is less than x, which is the same as x is greater than 1. So the second one is 2x minus 1. Let's put 1 where there is x. We'll end up having 1. So the limit as x approaches 1 from the left side is not equal to the limit as x is approaching 1 from the right side. Therefore, at x is equal to 1, we have got discontinuity. It's not continuous at that point. So all these 3 conditions are supposed to be met for you to conclude that that function is continuous at that point. You can't conclude just using 2. So you have to use this one, and that. Then you conclude now, okay, it is continuous at this point. It's making sense, right?
Yes, it's making sense.
Yeah. So I've got more questions under this. So here I've taught a lot of things actually. There are questions which they're going to ask you about, is it continuous at this point? And there are the questions I'm going to send you after the class, and then I want you guys to solve so that we see how far we have gone. Then we can also use the graph, like I've said, when they ask you to say, because without here, like this question, the way it was, find the point of discontinuity or the function such that you cannot use this technique because you don't know the number. So for you to know the number, you have to sketch. where you're going to have a circle, an open one, then there is a gap in between. That point, you get the point for x. That's why I had to get 1. So the only point at which this is going to be discontinuous, it is only at x is equal to 1. I can get any point, any number from here, 0, -1, -2, -3, is going to be continuous. You can even try it. Okay, unless you have questions.
So I have a question.
Please ask.
So to find if the function is continuous, you have to find f of that number, and
Okay.
then numbers as it approaches from the left and from the right.
Exactly.
Give you the same.
They have to give the same. Yes. If you have gotten the same answer from f of that number, and if from the left side and right side they are the same, then you conclude that it is continuous at that point. The moment you find that x limit as x approaches that number from the left and from right and left, they are the same, the limit exists.
Okay. Now, what if there are two equations where it says x is less than or greater than, sorry, x is less than or equal to that number, and another equation, x is less than or equal to
That number.
problem.
There are
X
two.
is greater
Yes.
than x.
Yes. So you are saying, let's say we have, let's just assume that we have got only two functions, right? That's your question?
Yes.
Then we have two functions where we are saying x has to be less than or equal to maybe 2. Then again they say x is greater than or equal to 2.
Yes.
No, it can't be. Then in that case they can't give you 2. They have to give you 3, because this is not making sense. We are saying that x is greater than or equal to 2. At the same time we are saying x is less than or equal to 2. In that case, then we are talking about from negative infinity to positive infinity. So it can't be in that. They can't, unless in between they are going to put another function. But what you are trying to say, I think I solved one of the questions. Let me show you. Let me send the link right now in the group. Limits. What you are trying to ask, I think, is this. Just a minute. What you are trying to ask, it should be this one. My network is not stable. Kazimo. Okay. Okay, I lost my network, but the one who was asking the question, are you still here?
Yes, I am.
Yes. So the question you are trying to ask is the same as the video I'm going to share with you in the group right now. It's exactly, I solved it. So I want you to watch that video. I'm sending now in the group. I want you to check it. But I'm going to send questions right now, which you guys are supposed to answer. Okay. Just check the way the video is looking. I want you to confirm if it's the same. X is less than. Then again, we also had less than there. So that is the type of question which can come, not the one we are talking about. You have seen it, right?
Yes, I have.
Yes, yes. Okay, guys. So we end here.